Good afternoon, everyone. This is Science Material 5. You're welcome to this live online session. I have recorded the first 20 minutes. I want you to listen to it. And then after that, we'll answer some questions that are attached to the video. Thank you.
Hello everyone, welcome to this live online class where we are going to study about the historical models of the atom and the atomic structure. So these are the keywords which we are going to come across in this topic. Atom, nucleons, proton number, nucleon number, isotopes, isobars, isotons, valence electrons, and radioisotopes. In the history of the atom and the atomic models, we will briefly look at the models of Democritus, John Dalton, J.J. Thomson, Ernest Rutherford, and Neil Bohr. The idea that matter was made up of particles that could not be divided was first suggested by an ancient Greek philosopher called Democritus. Democritus did something like this. Imagine you took something and you cut it into half. Then take that one half and cut it again into another half. Take that small half and cut it again. You will end up with something that is so small that you cannot be able to cut again. Democritus called this particle atoms. Atoms is a Greek word meaning uncuttable. These ideas remained like this for about 2,000 years until another scientist called John Dalton did some experiments and found out that matter is made up of tiny indivisible particles. These particles could combine to form what we call compounds. Around 1897, another scientist by the name of J.J. Thomson did some experiments, and he found out that actually the atom has other smaller particles. He discovered that electrons are much smaller than atoms. He imagined that the atom being like the plum pudding, where you have negative electrons stuck inside a positively charged material. So he found that the atom is divisible into smaller things. His model was called the plum pudding model. Around 1909, another scientist by the name of Ernest Rutherford did the gold leaf foil experiment and discovered that an atom had a nucleus. He also found out that all the positive particles are found inside the center of the atom, which he called the nucleus. In in 1913, the scientist Niels Bohr came up with his model. He described electrons like planets going round the sun, electrons spinning round the nucleus. He found out that electrons moved in fixed paths called orbits, with a set number of electrons. This is the model that will form the basis of what we are going to study in the next few lessons. The atom study still was not complete. Around 1932, another scientist by the name of James Chadwick discovered the neutrally charged particle in an atom. This particle, he called it the neutron, found within the nucleus of an atom. So to summarize what we have just gone through in the last few minutes, John Dalton in 1805, he came up with his model, the Dalton models, whereby atoms arrange in different combinations to make different compounds. Then J. Thomson in 1897 did his experiments and came up with the plum paddling model, where we have a material that is positively charged inside and with negative charged all around within it, stuck inside of it, the plum paddling model. Ernest Rutherford in 1909 will say that the proton, or the positive charged particle, is found at the center of the atom. And the last model we have just looked at is Niels Bohr in around 1913, who came up with the idea of the orbits and the set number of electrons per orbit. In the next few slides, we are going to look at what is found inside an atom. I know we have learned this previously, so I will expect you to have some basic knowledge on the proton, the electron, and the neutron. The atom is made up or is composed of two regions, two parts. One, the nucleus. The nucleus is the center of the atom that contains the mass of the atom. This is where you find the proton and also where you find the neutron. The atom is also composed of another region called the electron cloud. This is where you find the electrons. Now, the cloud surrounds the nucleus. The atom is made up of three kinds of particles: the protons, the electrons, and the neutrons. Because they are smaller than the atom and are part of it, they are called subatomic particles. The atom has a central nucleus. Protons and neutrons make up the nucleus. Therefore, these particles are called nucleons. Electrons go around the nucleus in parts. A fixed number of parts make up what is called a shell. Protons are larger than electrons. In terms of size, protons are much bigger than electrons. They have a positive charge, and they are found in the nucleus, the center points of the atom. Electrons are small and very light. They have a negative charge, and they orbit, they go round the nucleus. So as you can see in that diagram, the proton and the neutron, they are the center. The electron is the one that is surrounding the inner center. The neutrons are also large and heavy as protons. They have no charge at all. And they are also found in the nucleus like protons. So, to summarize, we'll find that the proton, again, has a positive charge and a mass of 1 AMU. AMU stands for atomic mass unit. The electron has a negative charge and it has no mass. The neutron has no charge but also has a mass of 1 atomic mass unit. From the table, it is clear that the nucleus consists of the protons and neutrons and makes up most of the atom's mass. Compared to the protons and neutrons, the electrons have almost no mass. The atomic number, or also called the proton number, and the mass number, also called the nucleon number. Atomic number is the number of protons in the nucleus of an atom. It is also called the proton number. It is written in subscript and it is indicated by the letter Z. All atoms of an element have the same proton number. Let's take, for example, hydrogen. Hydrogen has 1 proton, so its atomic number is 1. Another example is helium. Helium has 2 protons, so the atomic number is 2. And lithium has 3 protons, so the atomic number is 3. Beryllium has 4 protons, so its atomic number is 4. This atomic number determines 2 things. A, the physical properties of an element, and B, the chemical properties of an element. So, what are physical properties and what are chemical properties? Some physical properties may include things like smell, how a compound smells, color, the color of a material, how hard something is, the hardness, the melting, and etc., etc. Some few chemical properties include rusting, flammability, and corrosion. In a neutral atom, the number of protons is always equal to the number of electrons. Don't forget that. In a neutral atom, the protons are equal to the electrons. For example, let's take magnesium. Magnesium has atomic number 12. So a neutral magnesium atom has 12 protons and also it has 12 electrons. So always remember this, that the number of protons is equal to the number of electrons in a neutral atom. The next one is what is called the mass number or the nucleon number. The mass number is the sum of the protons and neutrons in the nucleus of the atom. The number of neutrons plus the number of protons equal to the mass number. In the previous lessons, we learned that the protons and the neutrons are found in the nucleus of the atom. These make up the mass of the atom. To recap on what we have just learned in the last few minutes, the atomic mass, or the mass number, is the number of protons plus the neutrons in an atom. The atomic number is the number of protons in an atom. We've also found out that the number of electrons is equal to the number of protons in a neutral atom. In the example that appears on the screen, the atomic number appears at the top. O stands for the symbol of the element, and the element name is oxygen. The mass number, or the atomic mass, is equal to 15.999, which is more or less equal to approximately 16. Let's remind ourselves. The atomic number equals to the number of protons or electrons. The atomic mass equals to the number of protons plus the number of neutrons. Let's do some practice on what we have learned today. In the first example, the element is oxygen. The atomic number is 8. The atomic mass is 15.999, which is approximately equal to 16. The number of protons is equal to 8. The number of neutrons is equal to mass number minus atomic number. That means, in our first example, the number of neutrons is equal to 16 minus 8, which we get 8. The number of electrons is equal to the number of protons in a neutral atom. So that means the number of electrons is also equal to 8. In our second example, the element is zinc, and the symbol is Zn. The atomic number is 30. The atomic mass is 65.39, which is more or less equal to 65. The number of protons is equal to 30. The number of neutrons is equal to 65 minus 30, which is equal to 35. The number of electrons is equal to 30. In our last example, the atomic number is equal to 3. The atomic mass is equal to 6.941, which is more or less equal to 7. The number of protons is equal to 3. The number of neutrons, again, the neutrons is equal to mass number minus atomic number, which is equal to 7 minus 3, which is equal to 4. The number of electrons is equal to the number of protons. So the number of protons is 3, the number of electrons is 3 because it's a neutral atom.
So we have a short exercise that I want us to practice. Type your answer in the chat and then I'm going to record for your score.
Hello, Andrew.
First question. The word atom is a Greek word meaning what? A. Uncuttable. B. Unreliable. C. Cuttable. D. All of the above. What's your answer? The correct answer is A. The word atom is a Greek word meaning uncuttable. Next question. Particles that are found in the atomic nucleus are also known as A. Atom shell, B. Nucleons, C. Nucleus particles, D. Elements. No. The correct answer is B. The particles found in the atomic nucleus are also known as nucleons and include the proton and the neutron. Question 3. A proton has approximately the same mass as A. Electron, B. Nucleons, C. Neutron, D. All of the above. Those are present, can you type your answer? Is it A. Electron, B. Nucleon, C. Neutron, and D. All of the above? All of the above? No. Nucleons? No. Someone says electron? No. The correct answer is C. Neutron. Next question. Almost the entire mass of an atom is concentrated in the A. Neutron, B. Electron, C. Subatomic shell, D. Nucleus. Someone says electron, another one says nucleus. The correct answer is almost the entire mass of an atom is concentrated in the electron. No. Nucleus. Most of the mass is in the nucleus. The reason is because that's where the protons and the neutrons are. Next question. Orbiting the central region of an atom are negatively charged A. Electrons, B. Protons, C. Nucleons, D. All of the above. Protons? No. All of the above? No. Nucleons? No. The correct answer is A. Electrons. The next question is question 6. An atom contains particles which have no charge and are called A. Neutrons, B. Protons, C. Electrons, D. All of the above. Electrons? No. All of the above? No. Protons? No. The correct answer is A. Neutrons. Question 7. The smallest unit of matter that retains the characteristic of an element is an A. Electron, B. Atom, C. Proton, D. Nucleon. The correct answer is B. B, atom, which is a Greek word atomos, meaning indivisible. Question 8. The center portion of an atom is called A, indivisible, B, shell, C, nucleus, D, none of the above. None of the above, no. Shell, no. No, the correct answer is C, which is nucleus. Question 9, 2 more to go. A blank has a positive charge and a mass. A, nucleons. B, neutron. C, an electron. And D, proton. Nucleons, no. B, neutron, no. C, an electron, no. The correct answer is D, which is proton. Question 10. Who confirmed the existence of the neutron? A, Chadwick. B, Thomson. C, Rutherford. D, Bohr. Thomson is not the correct answer. Bohr is not the correct answer. Rutherford is not the correct answer. The correct answer is Chadwick. Question 11. Fill in the blanks. Who proposed that electrons orbited the nucleus like the path of planets? Was it Rutherford? Was it J.J. Thomson? Who was it? No answer forthcoming because of time. Let me rush. The correct answer is no answer forthcoming also. Try and figure out that one and then answer it for the next period. Who suggested the presence of atoms and named them atomos? He was a Greek scientist. The correct answer is Democritus. Democritus. Who used a plum pudding model and discovered the electrons? Was it Democritus? Was it J.J. Thomson? Was it Neil Bohr? Again, because of time, the correct answer was J.J. Thomson. It is plum pudding model. He discovered the electron. 2 more questions. Planck developed the beginnings of the modern atomic theory in the 1800s. When you review your notes, you'll find that the answer is John Dalton. John Dalton. And the last question, and not the least, as you can see, it has an 8 on top, the symbol which is O, the element name is oxygen, and a particular number here which is 15.999. Using these details, answer this question. A, the number of protons in this is equals to what? Is equals to 8, because this is the atomic number. It's 8. The number of electrons is equal to, again, 8. Why? Because the number of electrons is equal to the number of protons in a neutral atom. So the number of protons and the number of electrons is equal to 8. The number of neutrons is equal to the mass number, which is 15.999, minus the atomic number, which is 15.99, which is 16, approximately 16 minus 8. The correct answer is equal to 8. The atomic number the number of protons or the number of electrons in an atom. So the number of protons is 8, the atomic number is 8. The mass number is the number of protons plus the number of neutrons in the atom, which is equal to 15.999, which is approximately equal to 16.
For more practice, I want you to go to the worksheet section in the website and download the worksheet. Hopefully, you'll be able to complete the activity, and in case you have any question, do not hesitate to let us know. Thank you.